to the concepts video on graphs of exponential functions. So first of all, let's look at some basic graphs, okay? So let's say we start with some function f of x is equal to 2 to the x power, okay? So how are we going to graph this? First of all, let's see what the vertical intercept is, okay? So by vertical intercept, I just mean our input is going to be 0. So this is going to give us 2 to the 0 power, and anything to the 0 power is just going to be a 1. So our vertical intercept is 0, 1. Okay, so let's just plot that, first of all. So we have 0, 1 is going to be a point, so right here. And then let's say, what else do we have? Let's say we plug in a 1, a positive 1. Then we would get 2 to the positive 1, which just gives us a 2. If we were to plug in a negative 1, we would get 2 to the negative 1, which would make it 1/2. Okay, so now we're down here. So our graph is going to ultimately look something like this. Alrighty? So you have something like this going on with that graph, and now let's say we have some other graph. This is a completely separate one. And now let's see what this function looks like as a graph. So again, if we plug in a 0, we get 1/2 to the 0 power, and again, anything to the 0 power is defined as 1. Right? So again, we have a vertical intercept of 0, 1. Now let's see what goes on around that. So if we plug in a positive 1 here, we'll get 1/2 to the positive 1 power, so that just gives us out 1/2. If we plug in a negative 1, we have 1/2 to the negative 1 power, which gives us, it flips around that fraction and gives us a 2, right? So now we have something that looks like this graph. Okay? So let's note some important differences between these two. So we see that, well, our A in this one was like a 1, right? The A in front, when we're looking at A times B to the x, the A in front was just a 1, so that's why we have this positive vertical intercept. As is this one here, the A was also equal to 1. Okay, so we have this positive vertical intercept. Here, the B is 2, right, which is greater than 1. So we see a case of exponential growth. Okay, and exponential growth just means as x goes to infinity, meaning as x goes to the right, then what is your function doing? And our function in this case is going to infinity as well. Like it's just going to keep increasing as x increases, right? And in the other case, on the right side here, we have exponential decay happening. Okay, because we have a function which whose values are decreasing as x goes along. That is, in other words, to say that as x goes to infinity, our g of x, in this case, so g of x, is not going to negative infinity, but it's approaching some kind of lower limit. And in this case, our lower limit is y equals 0. Okay, so here we actually have a horizontal asymptote of y equals 0, and if we look on the left as well, we have a horizontal asymptote of y equals 0 as well, except for this time, our function is only approaching it as x goes to negative infinity. So we just have different directions going on here. Okay, so in general, the function or the formula for an exponential graph looks like this. So a times b to the x, where a is our vertical intercept. So when our input is equal to 0, okay, and our b is called our growth factor, okay? So that tells us how is our function changing as x changes, okay? So there are kind of two separate cases we could run into. So let me just draw a little chart here. So on the first case of the two is when a is greater than 0, okay? So when a is positive, then we have a positive vertical intercept, all right? So this means positive vertical intercept. Okay, so this is going to look something of the following. So x and y, so a is going to be somewhere up here, as opposed to somewhere down here. It's not going to be because that's negative, so it'll be somewhere up here where a is. And then we also have two kind of sub cases within this one category on the left. When we have b is greater than 1, so when our growth factor is greater than 1, let's say it's like 2 or something, then our graph is going to look like this. Okay, and we actually have exponential growth going on, okay? So this is like, I'll just call this case 1, okay, case 1. And case 2 is when a, again, is still positive, but now b is less than 1. So our growth factor is now some kind of fraction, okay, such as 1/2, like we saw before. So then this would give us a graph that looks like that, okay? So this is case 2 right here. Alrighty, and now let's move over to the right-hand side. So now a is going to be less than 0. Okay, so that means we have a negative vertical intercept. Alrighty, so let me graph that real quick, and if I can get a vertical line going. There we go. So x and y, so now a is below our horizontal axis, okay? So what's really going to happen is these are going to kind of flip. So if b is greater than 1 now, then we're going to have a graph that looks like this, okay? Alrighty, so this is kind of like case 3 going on. Alrighty, so this is case 3 over here. And then case number 4, the final case, is going to be when A is negative, so we have a negative vertical intercept, and a B which is less than 1. Okay, so then we'll have something that looks like this. Alrighty, and this is case number 4. Okay? And a couple other important things to point out about exponential graphs. Something that I alluded to before was that when we have, I guess, a normal, or aka no shifting, no vertical shifting, that is, graph for exponentials, that has a horizontal asymptote at a function value of y equals 0. Okay, so as we saw before, sometimes our graph can look like this, where it goes to 0, right? Or it could look like this, where on the left side it goes to 0, or it could look like this, where on the left side it goes to 0, or it could look something like that, right? So basically on all of these, the horizontal asymptote is going to be the line y equals 0. Okay, unless you have vertical shifting, and then the horizontal asymptote will shift accordingly as well, okay? But other than that, there's one other important thing that I'd like to talk about is let's see, if our a was greater than 0, you know how I said that means we have a positive vertical intercept, right? So that means that a is somewhere up here, right, our vertical intercept. And if we draw the possible graphs that we could have, they're basically of this form, okay? And both of these, we recognize that, well, they're both concave up, right? Concave up like a cup, okay? So they're opening upwards, whereas if our a is less than 0, then that means our vertical intercept goes into the negatives, okay? And our possible graphs look like this, and they look like this, right? And both of these are concave down. Alrighty, so a, the coefficient all the way in the front, basically determines the concavity of our graph. Okay, so let's try an example problem. So we're going to sketch a graph of this function here, 4 times 1 over 3 to the x power. So let's identify what information this tells us. So we have a is equal to 4, which means that that's our initial value. So when we plug in a 0, we're going to get out a 4. Okay, this 1 over 3 is equal to our b, that's our growth factor, and we notice that this is less than 1. Okay, so let's start graphing. So we already have a vertical intercept of 0, 4. So here's 1, 2, 3, 4. So we have a vertical intercept right there. Okay, and then let's try to plot another point. So let's plug in a 1, a very simple x value. So we get 4 times 1 over 3 to the 1 power. So this is equal to 4 over 3. So that's another point, 1, 4 over 3. So now how do we see what this graph is really going to look like? So we notice that a, let's look back at our a is 4, which is positive, right? So that means that our graph is going to be concave up. Okay, so we're going to have a concave up looking graph. And because our b is less than 1, we also have a decreasing graph. Okay, so this is a case of exponential decay. Exponential decay. So now we can kind of get an idea of what it looks like. So it should be concave up like a cup, right? And then decaying as time goes along, or as x goes to the right. Okay, so this is our sketch of the graph. So the key things to remember when you are graphing exponential functions, so key ideas to remember are the following: that a is your vertical intercept, okay, and I'll write it out for us here. So a is our vertical intercept when our input is equal to 0. I won't write an x because sometimes your input is represented by t or some other variable, right? And then b is our growth factor, which determines long-run behavior, okay? Determines long-run behavior. And by long-run behavior, I just mean whether your graph is going to be exponentially decaying or exponentially growing or increasing, okay? So now let's look at some other things we can do with exponential graphs.
let's go. Start